Hey again, guys. Today we're going to take a look at using indirect measurement. And if you're having confusion with the similar figures, I would go back and rewatch that, because basically what indirect measurement is going to do is we're creating similar figures so that we can solve for our unknown. So our definition here, indirect measurement basically is what we're going to use if calculating the length or the distance or the height of an object is too difficult to do it directly. So for example, in this problem, I want to figure out how tall this tree is. It's a very tall tree. I don't have a ladder high enough to measure it. So what we're going to do is we're going to use indirect measurement in order to find out its height. So the thing I can do, because it's on the ground, is I can measure the shadow. The shadow it's casting is 10 feet. At the same time, this boy, who is 4.5 feet tall, is casting a 3-foot shadow. So what we'll notice is they're both at right angles to the ground. So what I've drawn is this little dotted line showing you that basically what I have is similar figures. I have two similar right triangles, which means their angles are the same, they're in proportion to one another. Since I know 3 of my 4 measurements, I can calculate my missing one using a proportion. So this is what I've told you here. The objects are creating similar triangles, so we can find it by setting up a proportion. So remember, there's always 2 ways that we can set things up, as long as we set up the like to the like. So I could set it up with the kid's height over the height of the tree, which is equal to the kid's shadow over the tree's shadow. So what you'll notice is I have height to height, shadow to shadow. Kid is on top, tree is on bottom. So you'll notice everything's lined up the way it should be. The other way I could do it is I could do the tree to the shadow, the height to the shadow, as long as I do height to the shadow. The tree is on this side, the kid is on this side, height is across from each other, shadow is across from each other. So it kind of makes sense. You can see the way it works. Height to height, and then the kid to kid, or you could do height to shadow, and then tree to tree here, and then like height to height there. So there's more than one way you can set up proportions again. So if you're trying to do it along with me and you set yours up differently, if you wind up with the same answer, you're sound. You set it up properly, you might have just done it in the opposite way that I did it, which is not a problem. As long as it's lined up, you're going to wind up with the same answer. So we're actually going to solve this problem. We're going to do it on the next board. So this is the problem that was drawn out for you, and when I have these word problems, I like to draw them out just so I can see the figure so you don't get confused when you're trying to set up your proportion. So we already drew this one. I wanted to know how tall is the tree. Here's my tree. If it casts a shadow of 10 feet. At the same time, this little boy, who's 4.5 feet, is casting a 3-foot shadow. So again, I'm just going to draw a dotted line to kind of make those into triangles and draw my little right angle symbol there to see that they're similar. I like to visualize it like that. Then it's easier for me to set up my proportion because I can see this side corresponds to this side. So I'm going to set it up with the tree height over the child's height. And then since I started with the tree, I'm going to start with the tree again. The tree shadow over the child's shadow. From here, we're just going to solve our proportions the way we've been doing. And again, if you need to, go back and rewatch those videos. So here I wind up with 3x is equal to 45, which means when I solve for x, x is equal to 15, and we're dealing with feet, so we want to label it. That means the tree is 15 feet tall. Okay, so just an indirect way for me to figure that out, since I didn't have a 15-foot ladder for me to measure the tree. All right? So we're going to take a look at another one. And again, I like to draw them just to help me visualize it. So I have a tower that's 75 feet tall. So I'm going to draw my tower here. Yes, this is why I don't teach art. It's a beautiful tower. What are you talking about? I have a tower that's 70 feet high, and it's casting a shadow. It's not telling me how long that shadow is. So I don't know what this distance is. But what you'll notice, these make a right angle, so this imaginary line creates a triangle. At the same time, there's a 250-foot building, and again, you're going to notice these are obviously not to scale since they look like the same size. That's okay. Which is 250 feet high, and it's casting a 25-foot shadow, so I know how long the shadow is. So again, you'll notice, obviously buildings are at a right angle or they fall down, so that means I have similar triangles or similar shapes here, so they form a proportion to each other. So again, I can set up my proportion in 2 different ways. Now I set it up one way up here, so I'll do it the other way. So here I'm going to go building to shadow. So I'm going to start here with my tower. My tower is 75 feet high. I don't know how long its shadow is. At the same time, my building that is 250 feet high is casting a 25-foot shadow. So remember, both of the buildings were on top, both of the shadows were on bottom, so I know I'm good, okay? I know that I set everything up the way that it should be. It was tower over its shadow, building over its shadow. So everything's lined up the way it should be. Here I'm going to pull out my handy-dandy calculator because I don't really feel like doing that math in my head, sorry. 75 times 25 gives me 1875. On this side I wind up with 250x. Then when I divide to get my answer, I find that x is equal to 7.5. We were dealing with feet, so I'm going to label it. So that means the shadow of this one is 7.5 feet. And I have a couple more examples. Same way. And again, I encourage you, it doesn't matter if you don't draw well, you can just draw it like a triangle, but label your angles and your sides and the measurements. You know it's easier to see what corresponds to what. So here I have a lamp post. Oh, that's terrible with the lamp post. Hang on, we're going to make it all fancy here. Oh, I don't have a yellow, I could draw a little light in it. Okay, anyway, we're not getting too caught up in the artistic side. That's not. I have a lamp post, which is 6.5 meters tall. Next to it is a mailbox that casts a 1.2 meter mailbox that casts a shadow of 3.6 meters. The sun must be pretty low to be casting shadows that long. So I don't know how long this shadow is. So again, you'll notice that these create similar triangles. So I know that they're going to correspond to one another and that I can solve them by using a proportion. So how long is the shadow of the lamppost? So I'm going to take the height of the lamppost. I'm going to put it over the height of my mailbox, if I put my decimal in the right spot. So I'm going lamppost to mailbox. So that means on my second one, I need to go lamppost shadow to mailbox shadow. All right. I have it set up. Now I can go about solving it. 6.5 times 3.6 gives me 23.4. 1.2 times x. When I solve for x, I find that it is 19.5. We were dealing with meters, so we want to label it with meters. Okay? And you'll notice I'm not going over every single step again. That's because we've talked about how to solve these. So I'm not going step by step. I'm doing the math mentally in my head. If you've forgotten how it is that I'm doing this, go back and rewatch the other videos, okay? All right, one more example to look at here. How long is the shadow of a 50.5 meter building? Okay, so here's my building. It's 50.5 meters. It says how long is the shadow, so obviously that's what I don't know. If at the same time a 1.5 meter man casts a shadow of 3 meters. So again, you'll see here's our triangles that they form that are similar. So we're going to solve for our unknown, okay? So I'm going to start with the man here. The man is 1.5 meters. He casts a 3 meter shadow. So I did height to shadow of the man. So I'm going to set that equal to height to shadow of my building. The height of my building is 50.5. I don't know what the shadow is. So you'll notice, however I set it up, the first ratio, I'm setting up the second one the same way. So as long as I'm picking the things that correspond, I'm fine. I could also set it up man to building and then shadow of the man to the shadow of the building. That would have worked too. So here, 1.5x is equal to 151.5, I believe. Let me double check that. If I can hit the right buttons. Times 3 is yes. My math skills are working today. Go. Then when I solve for x, 1.5, I find that I get 101. We were talking about meters, so it's meters. So the shadow of this would be 101 meters. Okay? So basically it's still the same thing we've been doing, and again, you've heard me say it over and over in these videos, it all comes down to making sure you set your proportion up properly. If you set your proportion up right, you're going to be fine. So you just need to think through that and take your time when you're doing that, especially in the next lesson, because we'll be talking about inverse proportions, which even I have to stop and think about because I try to do them backwards all the time. So make sure you're taking your time and thinking it through. Again, if you have questions, post them to the comments, or you can email me, ask me in class. Any of those ways will work. You guys have a great night.